Hi guys, this is Ms. Miller and we're looking at parent functions today. Basically, a parent function is the simplest form of a function or a specific type of function as close to the origin as you can get. Origin being the center of your graph, the point 0, 0. And we are going to use parent functions to understand how variables are related to one another. Basically, in physics, we're going to be looking at a graph and figuring out, well, what does this tell me about the x and the y variables? Now, here I have two equations. One, y equals 3x plus 5, and another, v equals 3t plus 5. While these have the same variables and they may look the same on paper, they mean two very different things. In math, you might see y equals 3x plus 5 and not think twice about it. We have y and x. We use those variables over and over and over and over and over. They have no meaning other than whatever is right here is your independent variable. It's what you're controlling. And what's right here is your dependent variable. It is what changes dependent upon this variable right here. So we would say, okay, well, what does 3 represent? In algebra, you would say, oh, teacher, the 3 is the slope, and 5, of course, is the y-intercept. It's, well, what y did I start with? And slope, again, definition, rise over run. It's how many y's up do I go for every x's over. Now, that's just your general basic function. In physics, we will never use y and x. We will use what's called a literal equation. It's where we use actual meaningful variables in place of y and x. So, in this equation, we have the variables v and t. V represents velocity and t represents time. So looking at this equation, it means something to me. So this tells me that my velocity, first of all, it's changing. I know this because as time increases, this 5 represents my y-intercept, okay, or in this case, my starting velocity. This represents my starting y. This would be my starting v. So I started at 5, whatever units are. Let's call this miles per hour, okay, or 5 meters per second. And this is the rate at which I increased my velocity. I must have increased it by 3 meters per second every single second. So now I can graph what this would look like. And if you were to do this on your calculator, which I hope you do, it would just be a linear function. And we can say that, yes, our velocity is proportional to our time, and in a couple units we'll talk about what that means a little deeper. Now, your standard, your Tennessee State Standard, and the purpose of this lesson is we need to be able to apply qualitative and quantitative measures to analyze data and draw conclusions that are free of bias. Again, we're going to be using parent functions, or the most basic functions, to determine the relationship between variables. There are 5 functions we're going to look at. The first one being a direct relationship or a proportional relationship here. So, you see, just like we saw, y equals kx plus b, k being our slope, you've also seen that as m, and b being our y-intercept. If you were to graph y equals x into your calculator, this is what you get. As you can see, as our x variable increases towards infinity, our y variable also increases towards infinity. Now, on your paper, I want you to manipulate this a little bit. Change the numbers. Instead of y equals x, where k is 1 and b is 0, manipulate it a little bit to where you can change that. What happens if this number k is greater than 1? What happens if it's less than 1? What happens if it's a negative? Either way, look at how those numbers change your graph. But that is proportional. We say y is proportional to x. An inverse relationship. Y equals 1 divided by x. That is your parent function. It's the most basic form of an inverse relationship that you can get. And all it means is, as your x variable, your independent variable, notice your independent variable or x variable is on the x-axis. That only makes sense. As x increases, y is decreasing. So, we can think of some examples here. The longer you stay up playing video games, so that's what you can control, okay? Your productivity is going to decrease, and it's going to continually decrease until you reach the point of being a zombie over here and you can't function at all the following day. I'm drawing a very poor zombie here. Okay, our third parent function looks like this. Y equals the square root of x. So here's our y variable, here's our x variable. Maybe this is if you're a bodybuilder and you're lifting weights. So this is the I don't even know. Y'all come up with an answer and give it to me. Never mind. I'm sorry. I found an example. Let's say, okay, we're going with the bodybuilder theme. The number of days you practice versus the number of reps you can do with the bar. Yeah, the bar is puny, but that's what we'll talk about. Let's talk about bench pressing the bar. Let's say you practice a lot and you keep on practicing. Naturally, those reps you can do are going to keep on climbing. They're going to continue. However, no matter how much you practice, it still starts to dwindle off here at the end. We had a really big leap right here where you gained some strength and some muscle and got swinging things, picking up those reps, but eventually you're going to hit your max, not be able to do too many more reps. So that is an example of a square root function. We would say the number of reps you can do is proportional to the square root of the number of days that you work out. Okay, next we have a quadratic function. This one's going to be very important as we go on in further units. First of all, the parent function is given by y equals x squared, and this is what it looks like if you were to graph it on your calculator. Of course, it curves up, and in algebra you learn that if you put a number here, it's going to change the shape of the U, and if you put a number outside here, plus or minus some value, then it's going to shift it up or down, and you guys will be doing that in your worksheet in just a second. However, let's come up with an example. Well, basically, as any one variable increases, the other one increases exponentially. And the last one here, again, this short video, you'll learn more as you do your worksheet. Just means you're not related. We have two variables, y and x, and we have flatlined. They are not even closely related to each other. We're talking about the time it takes to fill up the swimming pool and the time it takes you to run a mile. Those two things are completely unrelated, so you're not going to get any type of correlation. So we would say y is not related to x, or whatever your variables are here. So let's get started working on some patterns and recognizing these functions. The main thing you need to understand, or the functions we're going to be looking at the most coming up, are direct and inverse.